Have you ever pondered what shakes the very ground beneath our feet and creates colossal waves that engulf entire cities? Let's dive beneath Earth's crust, where the story of earthquakes and tsunamis begins. Earthquakes, in their simplest form, are the Earth's way of releasing pent-up energy. When tectonic plates, the massive pieces of Earth's crust and uppermost mantle, move past each other, they sometimes get stuck at their edges due to friction. But the rest of the plate continues to move, accumulating energy over time. Eventually the plate boundary can't take it anymore and the stored energy is released as seismic waves, and voila, an earthquake occurs, shaking the very ground beneath us. Now imagine this happening underwater. These seismic waves can displace huge volumes of water, creating a series of powerful waves we know as tsunamis. Imagine a pebble dropped into a pond. The ripples that emanate from the point of impact are similar to the waves generated by an underwater earthquake or volcanic eruption, but on a much larger scale. These waves can travel at jetliner speeds across the ocean, losing little energy along the way. When they reach shallow water near land, they slow down but increase in height, sometimes towering as high as skyscrapers, and causing immense destruction when they crash ashore. What makes earthquakes and tsunamis fascinating yet terrifying is their unpredictable nature. Despite advances in science, we still can't predict exactly when or where the next big one will hit, and their potential for destruction is unimaginable. From leveled cities to altered landscapes and massive loss of life, their impact is profound and long-lasting. So what can we learn from these mighty forces of nature? Each earthquake and tsunami leaves behind clues, helping us piece together the puzzle of our dynamic planet. They remind us of Earth's power and our need to respect and understand it. Now let's journey back in time to the earliest known earthquakes and tsunamis. The Earth has been trembling and creating giant waves long before humans started recording history. Our planet's seismic activity is as old as the Earth itself, but our understanding of earthquakes and tsunamis began with the first civilizations that experienced and recorded these events. Ancient civilizations such as the Chinese, Egyptians, and Greeks were among the first to document these fierce natural phenomena. The Chinese, with their extensive historical records, noted an earthquake as far back as 1177 BC. They believed these tremors were messages from heaven, disturbances in the harmony of yin and yang. The Egyptians, on the other hand, had a different interpretation. For them, an earthquake was the god Geb's laughter shaking the earth. Their understanding of tsunamis was limited, though mostly due to the geographical location of their civilization. The Greeks, however, had a more direct experience with both earthquakes and tsunamis. One such event occurred in 373 BC in the city of Halik. A powerful earthquake, followed by a tsunami, completely submerged the city. The Greeks believed that Poseidon, the god of the sea and earthquakes, was expressing his wrath. This event was so significant it was documented by various ancient scholars, including the philosopher Plato. These early societies responded to these events with a mix of fear, reverence, and curiosity. They attempted to understand these phenomena through their religious and philosophical frameworks, attributing them to divine intervention or cosmic imbalance. Despite their lack of scientific knowledge, these early records provided valuable insights into the seismic activities of the past. In essence, these ancient civilizations were the pioneers of seismology and tsunami studies. Their records, interpretations, and responses to these cataclysmic events laid the foundation for our modern understanding of earthquakes and tsunamis. Through their experiences, we began to comprehend the immense power of our planet and the seismic forces that shape it. From these early records, our understanding of these phenomena has greatly evolved. Today, we delve deeper into the scientific intricacies behind these awe-inspiring yet frightening events, drawing from the wisdom of the ancients while pushing the boundaries of modern science. The 20th century brought major strides in our understanding of what causes earthquakes and tsunamis. This era saw the birth of groundbreaking theories and discoveries that have been pivotal in shaping our knowledge about these powerful natural phenomena. One such revolutionary concept is the theory of plate tectonics. This theory, proposed in the mid-20th century, provided a comprehensive explanation for the occurrence of earthquakes. It proposed that Earth's lithosphere is broken into several large and small plates that float on the semi-fluid asthenosphere beneath. These plates are constantly moving, albeit at a slow pace. At times, they collide, move apart, or slide past each other. It's these movements that lead to the release of energy in the form of earthquakes. Another key development was the discovery of seismic waves. These are the waves of energy caused by the sudden breaking of rock within the Earth, or an explosion. They are the energy that travels through the Earth and is recorded on seismographs. Seismic waves come in two main types: body waves which move through the interior of the Earth, and surface waves which travel along the Earth's surface. These waves not only shake the ground we walk on but also help scientists to locate the epicenter of an earthquake and determine its magnitude. In the context of tsunamis, it's the underwater earthquakes, particularly those that occur at tectonic plate boundaries, that are of utmost importance. When an earthquake occurs beneath the ocean floor, it can displace a colossal amount of water. This displacement propagates waves that can travel across entire ocean basins at high speed, causing tsunamis. The understanding of these mechanics has been crucial in helping scientists predict the occurrence of these events to some extent. Modern technology like seismic monitoring systems, tsunami warning systems, and earthquake-resistant building designs are all fruits of these scientific breakthroughs. They allow us to prepare and mitigate the damage caused by these events. With this understanding, we can better predict and prepare for these events. Despite our advancements, earthquakes and tsunamis continue to have a profound impact on human societies. Let's take a look back at two of the most devastating events in recent history: the 2004 Indian Ocean tsunami and the 2011 Tohoku earthquake and tsunami in Japan. These catastrophic incidents serve as stark reminders of the sheer power of nature and its ability to reshape our world in an instant. On December 26, 2004, a massive undersea earthquake off the coast of Sumatra triggered a tsunami that affected 14 countries. It was one of the deadliest natural disasters in recorded history, with over 230,000 people losing their lives. The economic toll was equally staggering, with billions of dollars in damage and countless livelihoods destroyed. Fast forward to March 11, 2011, when a 9.0 magnitude earthquake struck off the northeast coast of Japan. It triggered a powerful tsunami that caused enormous destruction and loss of life. The Fukushima Daiichi nuclear disaster, which followed the tsunami, remains one of the most significant nuclear incidents in history, leading to widespread environmental damage and long-term health concerns. The human, economic, and environmental toll of these events is immense. Lives are lost, homes and infrastructure are destroyed, and entire communities can be wiped out in a matter of minutes. Economies can take decades to recover, and the environmental impact, including habitat destruction and pollution, can last even longer. These incidents underscore our vulnerability to nature's wrath. Despite our technological prowess and scientific understanding, we remain largely powerless in the face of such overwhelming natural forces. They also remind us of the importance of preparedness and resilience, and the need for ongoing research and development in earthquake and tsunami detection and mitigation strategies. Even with our advanced technology, we are still at the mercy of these powerful natural phenomena. While we have come far in understanding earthquakes and tsunamis, there is still much to learn. Our journey into the world of earthquake and tsunami science doesn't end here. It can't. The stakes are too high. Each new discovery, each refinement in our understanding, brings us one step closer to the ultimate goal: predicting these events accurately and responding effectively to mitigate their destructive power. So, what does the future of earthquake and tsunami research look like? Exciting, challenging, and absolutely crucial. Scientists are constantly developing and refining models to simulate how earthquakes and tsunamis occur, how they propagate, and how they interact with the land and the sea. These models require constant testing, validation, and refinement, a process that can only be achieved through diligent research and observation. Technology, too, plays a significant role. The cutting-edge tools of today and tomorrow, from advanced seismic sensors to high-speed supercomputers, allow us to collect and analyze an unprecedented amount of data. This data is the lifeblood of earthquake and tsunami research, offering invaluable insights into the Earth's inner workings. But it's not just about understanding what's happening beneath our feet. It's also about preparing communities for when the inevitable happens. Research into early warning systems, disaster planning, and community education is just as vital. It's about giving people the tools and knowledge they need to protect themselves and their loved ones. And let's not forget the role of collaboration. Earthquake and tsunami research is a global endeavor, requiring scientists from around the world to share their knowledge, their data, and their insights. It's a collective effort, one that transcends borders and disciplines in pursuit of a common goal. So, as we look to the future, we see a landscape of endless possibility and immense responsibility. The journey is far from over. In fact, it's only just beginning. As we continue to probe the depths of the Earth, we can only hope to better understand and prepare for these awe-inspiring yet devastating events.